Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show, bringing you another really fascinating guest today involved in creating a better tomorrow for all of us. Today we have the honor of being joined by Dr. Greg Ombach, who is Head of Disruptive Research and Technology and Senior Vice President at Airbus, the multinational aerospace corporation, where he's extremely passionate about managing tech innovation from idea to really broad market adoption, and his unique combination of technology, leadership, commercial expertise, together with sort of a really global perspective, having worked across Europe, United States, China, puts them in a really interesting position to drive their market success and all these really high-tech innovation spaces. As the head of disruptive research and technology, he really shapes Airbus's overall ability to be a global leader in innovation, future technologies across all these different divisions that Airbus works in. Prior to this role, he served as executive vice president and the head of battery systems business and group strategy and innovation at Dräxlmaier. There he was responsible for strategy of their business, leading product commercialization from concept to production. He was responsible for the first high volume production of the 800-volt battery system for the Porsche Taycan. Earlier to that, he worked at Qualcomm as a global vice president, general manager of breakthrough automotive technologies, and also gained experience in organizations like Siemens, Continental. Dr. Ombach holds a Ph.D. in electrical engineering from the Silesian University of Technology in Poland, a certificate of global management from INSEAD, and also has been working as a guest professor at Zhejiang University in China. A lot of interesting themes to get into today. But Dr. Greg Ombach, thank you so much for taking the time to come on the show today.
Ira, thank you so much for having me here today, and I'm really very happy that we are sharing this time together, especially it's so hot outside. I'm today in Munich, we have 30 plus degrees, and I had today morning, the chat with my boss, and temperatures in Toulouse, where we have our headquarters for Airbus, is going to be more than 40 degrees C this week. Therefore, it's very hot period, and we know we have to work as much as we can from our perspective to make this a bit more sustainable compared to this what's happening now.
Absolutely. And I'm sitting here on the East Coast of the United States, and we're experiencing similar stuff. So I feel it. I feel your pain there. But no, it's great having you, Greg. I'd like to start off as we typically do, but by really handing things over to you, just to introduce yourself a little further. Talk about yourself for a little bit about your background, obviously how you got started in electrical engineering, and I took a look at your 2001 dissertation analysis of the properties of selected transformer structures due to their suitability for high frequency power electronic conversion. All themes that for the next 25 years or so have followed you through your career. Talk a little bit about how this all got started off, if you would.
I definitely will, and thank you very much for putting that one as a question. Honestly speaking, when you start your career, you never know really where it's going to go, and it was exactly similar to myself. In the early days, I was really interested in electronics and building up the stuff, radios, and doing some even pirating around this one. It means not quite legal radios where you transmitted some voice and so on. Therefore, it was a great time, a great experience as well to learn how the technology works. And then once I went to my study electrotechnics, then I tried to learn more about why this what I'm doing is doing the thing which I'm building. How works really the transistors, and what is the next generation of the semiconductors and so on. How to program, how to use assembler to program the microprocessors and similar things. And then what I noticed when I was working on my electrotechnical thesis, that I need much more IT as well. It means then I decided, parallel to the electrotechnics, also to do the IT study and learn more about programming the computers, because I knew it already at that time that both fields are going to be much more coming together than just going separate. And exactly what was happening, it means in the time when I finished my electrotechnic thesis, you talk about the high frequency transformers, which was the PhD. I decided to go and do the PhD where I will combine the IT, which I learned during my study in electrotechnics, and work on something which is going to be already a combination of both. And it was where I developed the numerical methods for simulating of the high frequency fields. And this is why the thesis is coming. It means I developed the tools where there's combination of IT and combination of the physics for development of some electronics or electric circuits in order to predict how they work in the simulation. It was where I spent it couple of years at the university. It was in Poland because I born and I studied in Poland. And then when I was finishing my PhD thesis, it was a great time because the East Europe was opening up, and we had all opportunities to go abroad and have a chance to interact with the West, more or less, or US or Canada or Germany, you name it. And then for me, it was obvious that after I will finish my PhD, I would like to go and experience what the industry is about. Because the one thing being at university as assistant professor after PhD and experiencing these theoretical parts. But at that time in Poland, we haven't had too strong industry, particularly where you could apply the newest technologies. And therefore, I decided to move to Germany to learn new language as well at the time, and to start working for Siemens VDO, where I had the first opportunity developing the new technology. And I remember, like today, I was put in direction of electric drive systems, which should improve at that time the fuel consumption. And therefore, we haven't talked too much about CO2. It was coming later, but it's about the performance on the vehicle. And it's where I work, for example, on the electric steering system. It means not using hydraulic steering system, but electric one, and even not electrohydraulic. And then, of course, another big part was working on the powertrain. It means not having the combustion engines, but having something which is going to be more efficient and better in driving. It was electric. And this was a great time because it was not just about learning and developing new technology, which should be applied in the automotive industry, but also to understand how this, what you do in the pre-development, is going to transform to the product, and from product really to high volume production. At the time at Siemens VDO, we produced about 100,000 electric motors a day. Therefore, it was a huge number, different kind of, like the window lifters, like the seat motors, like the engine cooling, steering motors, you name it. And then, having the understanding about the impact from production on this, what you do in the pre-development and vice versa, was so crucial and was so opening learning experience for myself. Particularly, I remember my office where I work with my team was on the one side of the street, and the entire production facility was just across the street. Therefore, sometimes when I remember I was already bored about doing the new simulations, calculations, and answering or replying to the customer emails, I went to the production facility. I walked along the production line. I saw how all of these robots are working already at that time. It was more than 20 years ago. And then they are putting the stuff together, and then the final product is popping up. And already at that time, we had a quite high automatization rates or automatization in the production lines, which we talk above 60, 65, 70% automatization rate we had already in production lines. Therefore, a lot of robots which were doing and bringing things together. And later on, it went really to the 80+%. It means you had really limited amount of the people which were on the production lines. And from this, I learned a lot about developing the new technology for high volume production. But then there was a question, okay, what about how to protect this technology? This is where I took also the responsibility for the pre-development department, where it was not just about digital simulation. And then I used my past experience where I created the end-to-end digital development department, where we shortened development time to the market about 20, 30%. It means the entire, we call it A sample development in automotive happened already virtually. And we talk about electromagnetics, about mechanics, acoustics. We talk about fluid dynamic simulation. It means everything in one chain. And then this was great to do, but then you have to protect it. And then I was responsible also for the part of the pre-development where we had the IP and strategy for the new technologies. And then with IP or with the intellectual properties, we thought about, how to put the patents together in order to protect this what we are doing because of our competitors, like big companies like Bosch's, Continentals, like the Japanese companies, Panasonics, and so on the one side. On the other hand, also we thought about, okay, not disclosing all trade secrets we had. Therefore, it was always the game between, how to put the intellectual property right on the one side, on the other hand, not disclosing everything to your competitors. And then the third part, which was also quite important in this pre-development, was about benchmarking, because the benchmarking was about looking what the other guys are doing, because we are not always the most advanced in the technology. It means we were quite often the fast followers. Therefore, the technology which was available in the market sometimes from our competitors were even more advanced compared to this what we had. Therefore, you had to understand what they are doing, how to work around their IPs and then their products in order to deliver value to our customers. Sometimes in some categories like steering systems, we are more advanced than the other guys. I remember also the time where we had the automotive crisis. It was 2000, 2008, 2009. It was global crisis. But at that time was particularly a lot of the, I would say, impact on the automotive. And then there was a question, what we are going to do with the people in my department? And then we said, okay, why not to develop, because we didn't need them for automotive because automotive was relatively low. But then we said, let's be a bit more creative. And because I already was quite often to China, we saw that electric bikes are popping up and coming more and more. Okay, and then what happened was we put a lot of effort. We took some automotive components, and by the way, similarly like we did, the Bosch did the same thing. They did also created the e-bike drive systems, which are quite popular today. And we, as a Brose at the time, from the Siemens VDO to Brose later on, we also created the bike system, which, by the way, is making huge numbers nowadays. It took something from the idea where we had in 2008 to 2022, where the volumes are really big. It took about 10 years to the market. Therefore, you see, with the innovation, you have to be right with the technology, but you have to be also right in time. Okay. Right. And I tell you, honestly speaking, once we developed this technology around 2010, then we had not as much faith that this is going to go to the market very quickly. And therefore, you have to sustain quite long time till this hits the market. And therefore, all IPs which you are creating, intellectual property rights, have to be also done properly, because the life of the IP is about 20 years. Therefore, if the time to market takes you 10, then you could just protect 10 years afterwards. It is not quite a lot. Therefore, especially if you think about the different cycles of the industry. And then I had a great opportunity, and I moved from the automotive industry to the telecom industry. And for me, it was a big shocking effect, because if you think about the automotive, the development time of the new technology takes you about, I would say, to make the product, it takes you about 3-4 years. Now shortened about 2.5. I'm not counting the pre-development, just doing the product. And then you are about 7 years in the volume production, where at the beginning you're launching the start production, then in the second or the third, fourth, fifth year, you hit the maximum, and then you are ramping down. And for the entire cycle time in this industry, like automotive, is about 10 years, okay? Then I'm moving to the computer electronics, like the Qualcomm and making the chips and how the chips are going to be used and all of this, where the life cycles are something like 2-3 years. It means something like 4 times shorter compared to this, what I knew from automotive. Therefore, your development activities must be much more quicker. And therefore, you have to be much more, I would say, efficient in your decision-making process. It means you cannot drag the decision. You have to be on spot with your decision. If you don't do it right twice, then you are out of the market. Therefore, it was so important and so eye-opening for me, moving from the industry, which was 10-year cycle, to the about 2-year cycle. And later on, when I moved to Airbus, it's something like 30-40 year cycle. Therefore, it's another completely different dimension, which you have to take into account. But now in the Qualcomm, I had a great opportunity learning a lot about the new technology development and also what the technology licensing business is about, and how to use like effective licensing technology business in the different areas. And the goal was to create the licensing business model for automotive. And we knew it already. It was about, I started working Qualcomm about 2012. It means more than 11 years ago. And I spent it there about almost 8 years at this company. It was fantastic learning experience, and it was a great opportunity for myself also to bring my knowledge from automotive, because it was a time where we knew it, that in the couple of years, we didn't know exactly when this couple of years are going to be, that the automotive is going to be more connected, is going to be more digital, is going to be more electric, okay? And of course, with digital, we talk about more autonomy. It means where some additional functionalities will come with this. And then there was a question, okay, as a Qualcomm, what kind of a value proposition we can bring to the automotive industry? And we were already on the leading edge with digital communication. It means the entire 2G, 3G, and at the time 4G already. We knew it that this has to be on the cars, because you like to upgrade the software on the cars. You'd like to communicate with the car if you'd like to have a more autonomy and all of this. Therefore, we worked on this. The question was how to bring this technology to automotive market, which was completely different compared to the headsets, working with the mobile industry, which was much more dynamic, much more agile. Onboarding the new technology was the state of the art. In automotive, everything was controlled by car manufacturers, by OEMs, and then supply chain was somewhere below. It means it was you haven't worked quite well with supply chain on the same level, which was completely different in the computer in the electronics and consumer electronics. And then I had the opportunity being in US, being in Europe, and being in China, and creating this new technology licensing for automotive. And from that, we learned a lot, and we saw that the China is much more quicker than Europe around 2015. It was where I built up the new departments in China to address Chinese market. Also, a lot of learnings from that end, how quickly you could prototype the new solutions if you have a technology available. And we would be spending not months, but maybe years trying to agree on something in Europe. In China, it was possible to do in a few months. From the prototyping perspective, this experience was really incredible. And working with the companies, like the Sykes, Bikes, which are created the new cars at the time, and learning very quickly also with supply chain, which were bringing this new technology. It was really a life experience for myself. And And then I had the opportunity after this experience moving back to automotive, and you mentioned it before in the area of the developing of the new technology for battery systems for Porsche Taycan. It was a company, 75,000 people, Dräxlmaier. It was also connected to the vision of the previous owner and the CTO of the company at the time, where they saw about 10 years ago that the electrification will come. It's similar like we did at the Qualcomm, and there was a question how we are going to prepare for it. And then they opened parallel to the mainstream businesses. They opened the kind of the startup garage, and then in this garage they learned what does it mean to build up the battery system. And then they learned about it for a couple of years, something like 5-7 years. And then the first order came when the market was ready, and it was a Porsche Taycan order to develop 800-volt systems and to bring it to production. And I stepped in, I took it over, this department or this business unit, and then having a lot of the interesting time where we work on industrializing the technology which was created in the startup and transferring it to high volume production with 100,000 units a year. Therefore, it was the eye-opening and also live experience. But what I noticed at the time was that the situation is changing in the market, where till the time the OEMs were more or less giving away the technology development to the supply chain. But then with the new technology coming, like electrified, like more autonomy and more connected, then they notice that this horizontal business model where they are just giving away the stuff and writing the specification is not sustainable anymore for a long time. Mm-hmm. Therefore, they have seen the two things. The one thing was, of course, Tesla from the West Coast, yep. which was a great external force of the change happening to automotive. The second one, which we are not talking too much about, but because I was in China and I saw it and I collaborated with these guys, was a company BYD, Beyond yep. Dreams, which is from Shenzhen, south part of China. Very successful company. And by the way, this guy started making for mobile phones, making the batteries. And they learned how to make the batteries. And from these batteries, they started doing more and more components and systems, and then vehicles, and then buses. For example, one of the probably the most successful electric bus is coming from BYD. And also, if you look today in China, majority of the taxis are electric taxis driven by or made by BYD. Therefore, these more entry-level vehicles are coming from BYD, very cost optimized. But this guy started really with the consumer electronics and doing the batteries. Yeah? Yeah. And then for Tesla on the one side, the BYD on the other side. Important to say, both organizations very vertically integrated. It means they control almost everything from the mining to the end product. Of course, still working with supply chain, but the entire know-how and experience is in the verticals which they are controlling. And then there was, of course, the effect with the VW, with the diesel scandal, which suddenly pushed the entire industry, automotive industry, in the new direction. Even before we start talking about the sustainability, about the impact CO2 and all of this on our climate. Therefore, this was interesting change. And I had the opportunity during this time working already at this tier one supplier. And then I saw that the situation is changing, that the innovation-driven force is moving away from the tier ones in direction of the car manufacturers. And then I asked myself the question, where I would like to impact the world most. And then, of course, if you would like to use your experience from the computer or from some organization like Qualcomm about the technology, about the innovation from automotive, where this transformation from the combustion in direction of the electric driven mobility was on the edge already, then the next industry which has to transform is aerospace. And here I have a privilege being for about 1.5 years already, and together with the organization and teams across the board. We are driving, and we know we have to be faster, and we are pushing the new technology into the markets. And I can talk for hours about this one, but let's stop here. I know you have a follow-up questions, then let's then focus later on the aspects what we are doing in aerospace.
Yeah, absolutely. And Greg, I thank you for that really extensive overview of what you've been doing on this journey. It's amazing for everybody listening and watching. I really recommend you go to Dr. Ombach's ResearchGate page, where he has several dozen pieces of peer-reviewed literature on this period of his career. I learned a little bit, Greg, about torque ripple and other interesting things that you published on for a life sciences guy, which I thought were fascinating. But yeah, no, but clearly everything you've been doing in those couple of decades sets you up perfectly for where you are now. And, obviously you arrive, as you were just saying, a year or so ago at Airbus. Here we have, the world's largest aerospace company, and we interviewed Helene Huby about 2 years ago from Defense and Space. Clearly, the company is much more than defense and space. We know you as a commercial aircraft company. We know you as helicopters, and talk a little bit, reintroduce us to the company, if you would, and then when we go to the innovation part of Airbus and clearly your disruptive work, we'll get into that in a little bit. Airbus spells it out right away. It's like, we see decarbonized, connected, autonomous. This is the future of aerospace. Everything we were just talking about, of course. Walk us through a little bit of just the company. I'm sitting here in Boeing territory right now, but talk about Airbus, talk about innovation at Airbus, and a little bit, obviously, on your first year of experiencing. Hey, Dr. Ombach, we need you to fix X, Y, and Z across these business units. Take us a little into that part of your story.
Honestly speaking, I'm really very proud that I have opportunity working with this company in this industry. Because if you just look what happened during the last 50 years in area of the aerospace, it was just an incremental change. Even those incrementals were huge, but they were still incremental. It's the first time in this industry where we have to make radical change of direction parallel to the other incrementals we still have to be doing. Therefore, it's really exciting time. And I compare it to the automotive, something like about 5, 6, 7 years ago, where we also knew, okay, now it's time, we have to electrify the fleets. Yeah. We are going to be fully connected, where we are going to do the updates on fly over air. And we are going to bring more and more autonomy. Some companies went from top down, like Tesla, where you are starting having the autonomy from the beginning. Some others go bottom up, the level 1, level 2s, and so on, in order to get to the full autonomous cars. Now, this industry, the aerospace industry, and Airbus position is particular. Because we are leading the industry today. Therefore, if you are leading the industry, you have to put the pace of the change. You have to drive it, and you have to control it as much as you can, because it's your responsibility. And you have to, not just for Airbus itself, but for all of us in the global. Because if you are providing 50% of the global connectivity or connection, if you think about the aircrafts worldwide, and you are responsible for the industry for 2.5%, maybe a bit more, of CO2 emissions, without mentioning NOxes, without mentioning the impact on the contrails, on the climate change, and all of this, then you have work to be done. And if you are 50% for this, which is more than 1%, it's a huge contribution you could make. Knowing at the same time that the other industries are decarbonizing very quickly, or much more quicker, because it's easier, for example, for trucks to put the hydrogen on board and drive those trucks already with the impact on the CO2 much less compared to this what we have today. If you think about the commercial, or about the personal cars, which I'm driving the electric cars now over the last 5 years or so, and honestly speaking, there is no reason to have a combustion car as a personal car. You can do everything in different conditions with electric one, especially if you think also about the development of the new battery technologies, which are much more safer, like the solid state, for example, which is going to be the next generation of the battery technology, which is going to solve the problem with so known thermal effects. It means if you think about the thermal hazards where the battery can potentially have some problems, then this is going to be solved with the solid state. Independently, those cars already today are much more safer compared to the combustion if you think about the fire hazard, because they have, if you look the global numbers, percentually it's about 10% less compared to the other ones. Therefore, this is already a great place to be. Now, you have to take all of this, what you learn in the other industries. If you think about automotive, if you think about electronics, digital, and now you are applying it more and more into aerospace. Although aerospace was already very advanced, then because of the cycling time, which I was mentioning before, which in commercial is 30 to 50 years, probably more 50 than 30, then you are not developing the new product every year as we did at Qualcomm, okay? Sure. Or every 3-4 years as I did in automotive. You are doing it every 30, 40 years. Therefore, this is a big difference. Therefore, the next product which has to come up during the next decade has to be the product which is going to last for the next 30, 40 years, because this is the nature of the industry, and this probably to change would be very difficult because it's about the business model which is behind and about the cost of which you have to invest in order to make such kind of the development and the production. Doing it more frequently probably would be not sustainable from the commercial perspective anymore. Now, if I will just look, and I have the privilege in this organization and working with these fantastic teams, which are global teams. I have teams which are in the West Coast, which are in Europe, in the all kind of the Germany, France, UK, Spain. Also the teams which are located in India, in China, in Singapore, therefore global footprint. And we have a privilege working with the 3 business units which we have. The one is the commercial, as you mentioned, which are doing the aircrafts like 320s, like 321s, like, for example, 220s, which is the aircraft which we took from the Bombardier, and then with helicopters, and also with defense and space. And then you would ask, okay, what kind of the new things are coming in those directions? And I tell you, if you say, of course, the sustainability is in the center. This nobody's discussing anymore, because we committed by 2050, we are going to be net zero. Therefore, in order to be net zero by 2050, it's not about just one thing you are going to change. Right. It's about the entire value proposition you are going to address. And here I will talk more in detail later, but it's addressing not just how the aircrafts are built, but how they are operated as well. And what is going to happen after the aircraft is coming back after this 30, 40, 50 years, how we are going to recycle it and how we are going to reuse those materials in order to close this wheel of the sustainability in the proper way. And therefore, it's really very exciting time. And I tell you, I think if I could pick up again the industry in which I would like to be now, this exactly would be this one. Therefore, I'm really so pleased and so happy that I have this opportunity, because the changes we are doing now in disruptive research and technology and other parts of the organization are going to shape this industry for the next 30, 40, 50 years, which is so fantastic.
Absolutely. And now to drill down on disruptive research and tech, which you lead, and again, anyone can go to the Airbus webpage and look at this section, and there's an extensive list of projects that Dr. Ombach is leading. We won't go into all of them, or even a decent chunk of them, but Greg, I thought a couple, and again, talk to the degree that you can, because I know some of this is really cutting edge and moonshot style, but I thought I'd line up some of my specific points with some of the topics we touched on other shows. And one of them, just because I'm a biology guy, I was just so intrigued by the section on the website on biomimicry and sort of, as you described, biologically inspired engineering. Obviously, we know that 100+ years ago, there were these Wright brothers, fellas, that looked up in the sky and saw birds. But here, you're taking this to a whole new level in terms of looking at the migration of geese and the way they swarm, and birds of prey and their wing structure, and even this really cool one on dragonflies and how it can see in 360 degrees. Say a few words to what you can talk about in terms of the biologic-inspired engineering of disruptive R&T.
Oh, absolutely. Look, I think the nature is always the best example which you should charge from, because it's developed over billion of years, and then if you just look precisely and you try to figure out better what works and why it works like this, then definitely it can have a positive impact on this what you are doing. And now, before I will jump on this biological thing and how this impacts us in our thinking, it's important to say that this is not just about one area which is going to impact us, because if we would like to be net zero by 2050, then we have to do the combination of the things. And for this, the nature can impact the different areas of this what we do. If we just think about, I will just mention a few things which has to happen, and then later on we'll dive in more and more. But first of all, we have to exchange the existing aircraft to the latest generation aircraft. This is the one thing. Then we have to work on the optimization and infrastructures. It means how you operate the aircraft and how the infrastructure fits with this one. Then we talk about sustainable aviation fuel. Then we talk about some other disruptive technologies which have to come up.
Yep.
And of course, the other market-based solutions or measures in order to compensate the gap on the CO2 which you cannot cover with the other ones. And now, coming back to the nature, and you start mentioning it, and I will just give maybe one or two examples. The one example was exactly the fellow fly. And this connects to this operation and infrastructure part, because the fellow fly, it was, if you just observe how the birds are migrating, then you see that there is not one after another. They are forming the pattern, and then the birds which are a bit more back, they are using the energy from the birds which are in front of them, and then they are exchanging, of course. And similarly to this, probably you could see it, not the same quite effect, but similar. If you see the trucks on the highway, and then one truck after another truck, then the air drag on the next truck is less than on the first one. Therefore, the second truck can save some fuel. Now, if we are coming back to the birds and we are observing them, what we did was we put it to two aircraft, 250s, which they're flying from Europe to US, and then the second one was in the proper distance from the first one. Then you were able to use the air turbulences and lift the second aircraft during this. And then we noticed that you can save between 5 and 10% fuel if you do it right. It means at 5% we save. We saw that the difference on the second aircraft. Then, of course, if you would start optimizing this entire operations with the proper air traffic management, with the optimized flight trajectories, where you don't have to circle before you land because there is some queuing or whatsoever, then in total, just from this, you would get about 10% fuel efficiency better. Therefore, looking the nature and then trying to bring it into the technology always helps. Then another one which you mentioned was about the Dragonfly. The Dragonfly, we love that one because it's about putting the new sensing technologies on the aircraft. And in this case, we are putting some cameras which we use for visual, we call it visual-based landing, but it's not just about landing, it's also about flying or taking off or controlling the aircraft. It means you are providing additional senses to an aircraft to support pilots during the operation.
Right.
And this, of course, is reducing the stress of the pilot and then increasing the safety during the mission. And the mission is, once you are getting in on the aircraft, once the pilots are there, then you are taxiing, you are taking off, then you are in the cruise, you are preparing for landing, and then you are on the coming back to going to the gate. Therefore, all of this or this new technology, like we call it Dragonfly with additional sensors, can improve and help with the improvement of the safety. And because it's uploading a lot of the things from the pilots, they could focus really on their mission. They don't have to do everything else as they do today. And of course, this can be also in combination with the air traffic management. Once we are putting more automatization to the aircraft, then when you are optimizing the flight trajectories, it's going to additionally improve the aircraft efficiency. Therefore, this is a combination of the safety plus absolutely the CO2 emissions by reduction of the fuel burn. Therefore, we love that one. And then recently we worked on another interesting one where, for example, it's maybe not quite from the nature, but it's from the other industry. We are using the LiDAR from automotive, which is used for autonomous driving, in order to detect the infrastructure around you or other moving people, vehicles, you name it. And we integrated this technology on the helicopter. And you can also read it on our internet page. And then with this technology, we are able to detect or provide additional information to the pilots, like, for example, cable detection, which is really very important if you think about flying the helicopter. Probably one of the most dangerous things are when you are hitting the cable with the helicopter. And it happens quite often because you don't see them once you are flying with the high speed. And this technology can detect them. Now we are bringing it more to the product development in order to improve the safety. And of course, this opens the entire new possibilities, because if you think about this solution, it can be also applied, for example, to the eVTOLs, because if you would like to them flying in the cities or in the places where you have a lot of the cables, and we have everywhere cables here, then you have to provide more safety into those vehicles. And this kind of the solutions, as I mentioned, are the potential technologies which are going to improve the safety and allow operation of such kind of the new vehicles coming in.
Excellent. And alongside that, and again, this is, you have this section on so-called Industry 4.0 and sort of this future-focused, intelligent, and digital industrial ecosystem. And obviously, this is something that you spoke about early on in your career in terms about the simulation and virtual development technologies, things of that nature. Obviously, that's going to play a key point in everything from the digital twinning, let's say, of these novel aircrafts, but also on through. I mean, you have this, and the topic of quantum has been kind of hot lately, but you have this whole really interesting thing in quantum sensing, and that, as you were just pointing out, when you have all this stuff and all this data, you better have a decent system to crunch it in real time. Talk about just Industry 4.0, if you would, but some of these sort of bleeding edge tools that you have to use as well, in terms of whether it's the AI, the quantum technologies. Walk us through a little what you see there.
I think, honestly speaking, you could open any part of this exciting journey here from the disruptive technology side, and it's great because on the one side you could connect them with the other pieces very nicely. Okay. And if you took just quantum, or you took the machine learning, AI, you name it, all of this is going to have it has already the impact on this, what we do and how we do. Okay. And therefore, in our organization, we are privileged, and it was done something like a couple of years back, where the entire restructuring happened. And then what we said, we have to, from 100+ different technology roadmaps across the board, we said we have to simplify it. And then we have to have something like 11 level 1 technology roadmaps. And then we go on the level 2s, level 3s, 4s, and so on, in order to go deeper from the system of systems to something like component level, more or less. Okay. Now, from this 11 technology roadmaps, we said that 6 are going to have the impact short term on Airbus. Therefore, we have to call them fast tracks. Okay. And those fast tracks, their responsibility is to identify and define the technology roadmap in the given area. And I will give you a couple of examples coming back to industrial and so on. And mobilize the entire Airbus in order to cover those gaps if they are specified or if they are identified on the technology roadmap. And now those 6 are following. The one is industrial, because we said all of the industrial systems we know today are going to be different tomorrow, because there's too much, so many new technologies coming. We have to implement it for our next aircraft generations. Okay, therefore industrial is one, and I will give you some examples later. The second one is, we already touched on this so much, is electrification, because we said the aircrafts, independent in which part of the organization you are going to look. The commercial aircrafts are going to be more hybrid. It means we are going to see some hybridization on the commercial aircraft. This will happen. Then the second one, if you think about the helicopters, here we are talking about also hybridization, and I could give you a couple of examples later, what is happening in the area of helicopters. Okay. And not mentioning the entire eVTOLs, where it's going to be, I would say, full electric. Therefore, it's not going to be hybrid; it's going to be pure electric. And then in defense and space, on the helicopters or the defense aircrafts, you see a similar trend like you see on the commercial and the helicopters as well. And the entire space, of course, was already driven. If you think about the satellites, the solar panels and batteries. Okay. And this efficiency of those equipment is even more and more important. And there's one crazy one, you could say, which is really disruptive. We looked at this something like about, I would say, 2-3 months ago, where we did a small demonstration here in the site of the Ottobrunn in Munich, south of Munich, where we see the opportunity. And there are the couple of the projects already on the European level, but also in Asia and China, particularly in US, where you could put the solar arrays on the geo orbit, and you could beam as a microwave energy from this to the Earth. Yeah. You could pick it up here, and you could transfer it, and you have a 24/7 energy source, because you are weather independent. There's no day and night, because we are on the geo, and this would require the new, better solar systems. This would require the robotization in the space, which we have to do nevertheless. This is going to require as well a new electronics system, because it has to operate under the difficult conditions. And we are aiming for this. You know, we believe this technology can come true during the next decades. And therefore, we are working on such kind of a crazy project as well, which are really disruptive if you think about what you could do already today on the Earth and what you have to do in the space. Yep. Therefore, electrification is the second. The third one, which is really very important, which connects all of this, is connectivity, and which we touched so much about, because 5G is already today, we know it. 6G is already in the standardization. 7G is already in the laboratories. Therefore, if you just think how fast this is changing, and today we are getting our signal from the mobile net, which is hardware driven mostly, which is sitting on the Earth. The next generations are going to be moving to the cloud and are going to be more software driven, and is going to be more space driven as well. Who said that your mobile has to be driven from the mass sitting close to you? Can be driven from the satellite, as an example. Okay, therefore, this is changing in that direction with the incredible fast pace. Now, from the connectivity, we go to the new materials, because the new materials are the materials which are going to be, I would say, even more performant than we know today. And here we talk not just about performance during in the product, but also in the recycling period when you are bringing it back, and how you are going to recover the value of the materials. And here you are going to need, and we touch on this later, because it's AI and the quantum are going in the similar direction. You are going to need also the new capabilities of the quantum computing in order to develop new materials. And it's what we are already trying to do by collaborating with universities and other players. We announced something, for example, with BMW. We are working developing of the new material for the fuel cell, which we would like to bring to our hydrogen aircraft in the future. And this is based on the quantum algorithms in the future, on the quantum computing as well. And then we are talking about the next fast track roadmap, which is autonomy. And we touched so much about autonomy. It means bringing more safety into the different businesses we have. If we think about operating and using our products, which have to be more autonomous, and in order to offload the pilots at the beginning, it's going to go step by step, and the Dragonfly is one of these examples, or Vertex about this helicopter LiDAR, the cable detection, and in case of the for example, the pilot incapacitation, where he's not able to fly helicopter anymore, the system takes over, finding the new landing pad, and is landing safely. Therefore, these are the examples which are improving safety, and is about the autonomy roadmap. And the last one is the industrial roadmap. Okay, and industrial roadmap, we are talking here about improving all our kind of the how industrial systems are going to look like, in the combination of the new technologies, where you could think about more robotization, but also using the visual machine learning, then of course, energy resource optimized, in order to improve our productions and make them more I would say automatic, and with a high automatization rate, but also keeping the flexibility, because the problem is, if you think about the aircraft, that every aircraft is a bit different, not from outside, but from inside. Therefore, you still have to keep a lot of the flexibility if you are doing automatization, in order to be able to cover those flexibility. Therefore, there are plenty of challenges, but with the 6 roadmaps which I mentioned, we are covering, I would say, this most fast-paced changes which are happening not just in this industry but globally. And I will just finish one thing, because I'm so passionate about it. It's, as I mentioned, it's not just about this industry. It's also about automotive. It's also about electronics or computer electronics. It's impacting us every day. And the biggest, I would say, value is to find out how you could combine these industries which are already using those technologies, and trying to speed up the time to market. Because at the end of the day, it's not about making some disruptive technology. It's not about the invention, it's about the innovation. But innovation happens firstly when you bring it to the market, when you create the value for your customers. Okay. Therefore, it is what I was explaining at the beginning, when I had the opportunity learning how to do from my ideas, develop the new product at Siemens, or new technology, how to make out of this the high volume production in order to address your customer needs. And the same thing applies here. It means it's not about creating too many new ideas. It's about creating enough good ideas which you can, in the fast pace bring to the market. And we are not talking about here 30, 50 years, because the times are changing also in this industry. You have to be much more quicker because you have a hardware related things, you have the software related things, you have a combination of both on the vehicle, on the infrastructure. Therefore, you could manage, or we can manage already, doing much more faster in the different areas. And it's what we are trying to do and what we are doing every day whilst we are coming passionate to our offices and collaborating with the guys across the world.
Absolutely. One of the things I forgot to mention when I did your bio is that you're also, in addition to all that you mentioned that you're doing, you're also a member of the Forbes Technology Council, and you recently wrote this article a couple of months ago. It was entitled "How Venture Client Units Are Revolutionizing Corporate Innovation," and you introduce, Airbus has things like Airbus Ventures, which are, I guess, more maybe traditional corporate venture capital stuff. But this concept of the venture client unit is a little different. And I was wondering if you could walk us through some of these ideas. Of course, the role in general that the young, the sort of the startup innovators have in this space, and ultimately how that all fits in with the grander innovation puzzle that you're involved in.
Ira, and thanks for this question, because I particularly love the questions around the innovation and governance and startups and all of this, because I'm a strong believer that the things which we are doing at corporates over the last 20, 30, 50 years, where we're really very good at, now we are still going to be doing, but there is a new opportunities which we are popping up during the last decade or so, which are exactly the startups. It means if you just look how much money is invested from the venture capitalism into the startup world, during the COVID was 600 billion, last year about 400 or similar. Therefore, it's a huge amount of money which you see coming in direction of the startups, because they are taking this money and they are riding, or they are driving for you the proof of concepts, more or less. It means you as a corporate, you don't have to develop the technology somebody develops already in the startup, because they are, in many cases, if you think about the new stuff, more experienced, they are faster, they are well financed, and they are very hungry. Therefore, they are working 24/7 in order to deliver. Okay. Therefore, the question is not to compete with these guys, but how to find collaboration mode with such kind of the startups. And honestly speaking, different corporates did differently, but there was the one main trend a couple of years back where everybody was doing the some incubations of the startup, the form where you picked up the few startup. Oh, it's great technology, let's help them build up whatever. And then you are incubating the startup, then you have a technology, then you're asking, okay, this is already mature enough, who is going to use it in our organization? And then the problem starts, because you don't know how to apply this technology into your business and create value.
Right.
Therefore, this one, fortunately, is behind us and we stop it. And when I was working at automotive, there was a new method appearing on the horizon, and it was the venture client unit. Okay, not venture capitalists, but venture client unit.
Right.
And the venture client unit works 180 degrees different. It means what you do, you are finding the problem you would like to solve in your organization. It means doesn't matter which part. It could be operations, it could be marketing, it could be technology, it could be engineering, you name it. Okay, it could be from the process, it could be from the product perspective, doesn't matter. And then you are checking if this is the problem you would like to tackle internally, or maybe there's external solution which is already developed to the something like fits, like I would say 80% to your problem. And it's exactly what the venture client unit is about. This is the unit in the organization which makes helps identifying the problems the organization should solve, and has enough connection to the outside world to identify few startups which have the proof of concept, which are very close to your problem. And then their role is to match it, to drive the proof of concept for the problem, to solve the problem, and then helping organization finding the collaboration model with the startup. And there could be different. If the solution is so critically important for you, it could be merger and acquisition. If the solution is important, but you don't have to have exclusivity rights, then you go, for example, for normal or technology licensing or normal collaboration like with the other suppliers. Therefore, normal way of the collaborating with the supply chain. Because from the startup perspective, the most important thing is the order, which they have to receive from you as a corporate. If they have the order and they can deliver to you the solution, then the venture capitalist is going to put the money on these guys because they have a prospect, okay? And it is how the model works, and the adoption rates are huge because in the old model, from 100 whatever startups we had in the incubation, it's something like 10% were maybe successful, okay? It means the rates were not high. Mm-hmm. With this new model, we promise ourselves at least 50-60% adoption rates from the proof of concepts we are transferring to our organization. And it can speed up incredibly your innovation edge as well. Therefore, it's why I'm so passionate about it. It's why we are implemented it already last year and we are rolling it out. And it's going to be the global solution for Airbus to work together with startups because it's so efficient and so powerful and it's bringing so great results.
And I appreciate you sharing that, and I very much enjoyed the article when I read it, and you know I like seeing, you know, again, these innovation structures take root, especially in areas like this. So now I applaud you for this one as well, Greg. Yeah, as we're talking a lot about speed of innovation, and obviously the shrinking of these timelines, as you've been mentioning. I just have to ask, while I have you, being an expert in this, I'm interested in, not just the speed of innovation, but innovation around speed. I like to fly. I'm a very impatient person. It would be really nice to shoot over to Europe, have lunch with you, and come back and have lunch with dinner with my wife. Where are we with regard, whether it's supersonic, hypersonics, whatever? I mean, is speed an issue or on the drawing board anywhere? It doesn't have to be Airbus, but what's your general perspective in 2023 on? I know that the Concorde went the way of the Concorde, but anything happening on the horizon that's exciting as far as getting around this little planet a lot faster than we do it nowadays?
I think the speed is important. The question is, at the end you have to also put into the equation the sustainability aspects of this.
Sure.
And also, who is going to be your market? Is it just a few people? Or is more like we have today with the commercial aircraft. Therefore, yeah. I think from the Airbus perspective, we are putting on focus on the sustainability and bringing as many people as possible from A to B. Sometimes it takes a bit longer compared to the supersonic, for example, but also it has to be comfortable. Therefore, you have to have nice cabins. You have to have all what is needed on the aircraft to make it happen. Yeah. And keeping in mind, it has to be really working also in 20, 30, 40, 50 years from now. It's why we are spending so much effort in developing the new aircraft on the one side. On the other hand, we are also putting on the new technologies, like, for example, the hydrogen aircraft, where we are working on and you would never imagine that the company like Airbus is going to push for the liquid hydrogen aircraft, where we are going to the tanks, which today, maybe from the spacecrafts like Ariane Group, yep, where you have the liquid hydrogen with the temperature minus 273 degrees C, and you are going to use it as a propulsion for your aircraft. Therefore, this is so crazy enough on that, okay, that I think that supersonic in comparison is just a simple thing, okay? It's still difficult, but it's simple. Therefore, relatively, okay, there are a lot of work which is happening around the supersonic. I'm not working in my department and with my people or our people here from Airbus on this technology today. We are observing what's going on. There are a couple of the startups we have a contact with, which are getting the nice investments, and they are trying the different solutions there. I think it's important. It's great that the people are doing on this. but at the same time, you have to put, as our CEO always says, priority on the priorities you have. And we have other priority on the priorities, or I would say we have other priorities in this case, which are more important and more time relevant than the supersonic. The supersonic is not going to be the game changer. If it comes, the game changer is going to be hydrogen, because you could imagine we will be not able to get net zero in the next 30 years if we don't do combination of those technologies. And supersonic is not going to help us with that one. Therefore, the priority number, or putting priority on the priorities, is about net zero 2050. And this means the new aircraft generation with the new wing structures. We are doing crazy things, you know. You could read about it, like X-wing, where we are changing the wing profiles during the fly and during landing and all of this in order to improve efficiency of the aircraft. We are working on this hydrogen-powered aircraft, which we still don't know if it's going to be burn hydrogen or it's going to be fuel cell. We are running in parallel to find out what is the better solution during the next time. And of course, we are working very hard to be able by 2030 that all aircrafts we produce are going to be sustainable aviation fuel certified. Therefore, you will be able to use sustainable aviation fuel. Already today, you could blend about 50% or even more, and it works. But by 2030, all aircrafts have to be 100% SAF, sustainable aviation fuel certified, because these are the milestones which are going to guarantee that this industry and the way how we move from A to B is going to happen during the next 20, 30, 50 years from now, okay? Therefore, we have a huge obligation to reduce this CO2 footprint and improve safety at the same time. It is where our priorities are. And honestly speaking, I think this is so exciting, and it's a combination of so many new technologies coming in. Then there is a place for everybody from the various industries to help transforming this industry as well. And not mentioning, direct air capture. Here is behind me. It is about this market-based measures. You know, you have to also capture somehow CO2 in order to still offset this piece of the CO2 which you cannot reduce. And here in the area of the internal venturing, because I'm always coming from the position that you cannot have the innovation department in the corporate. Everybody is allowed to innovate. What you have to do is you have to have some department which is helping to governing it, to provide the common language, who is able to make the proper support during this innovation phases. And the one part of organization is about taking the internal ideas, and if they are sexy enough, and then it depends, it goes through the process, then scaling it up, okay? And what we are doing here in this area, you could imagine ISS station, which are flying the astronauts on the orbits. And at that time, the part of the Airbus developed a system which is capturing CO2 from the air, which astronauts breathe, in order to make the life support in the spaceship on the ISS station. And we took this technology, and then with the small team, we developed CO2 capture, or we call it direct air capture, here on the ground, in order to first support, for example, the vertical farming, because the green stuff, when it's growing, requires more CO2 than it's growing faster. And you don't want to bring it from the burning the fuel or gas or whatever, because then it's not going to be sustainable. But you could bring it from the direct air capture, which is going to be sustainable way of capturing the CO2. And this is, we are talking about a small scale, something like, I would say, 10 tons per year or 100 tons per year. But this can scale up to much bigger numbers. And this is where one of the venturing teams is working on. And we also found the way how to, I strongly believe, how to make it successful at the corporates, which we are trying now as a proof of concept, how such kind of a venturing can operate and work and be successful. And I can talk about it next time, something like in the year or so, once I have a proof that it works. Okay.
Okay. Well, we'll definitely do a follow-up on that. But yeah, I mean, speaking of that and coming sort of to a wrap up, Greg, I mean, obviously, you have this amazing portfolio. I'm so excited for you and the team. You also, you get out there a lot, doing a lot of public facing stuff. I read that you were Ecosystems 2030, I think a couple months ago, the Automotive Evolution Manufacturers Group. Anything else coming up that we should know about in terms of the public facing stuff for the rest of 2023, places that you're going to be talking, conferences, places that we might run into you and meet you, anything else on the calendar that we should know about per Dr. Greg Ombach and Airbus, please let us know.
Definitely. There are a couple of the things, of course, going to external is very important. It's so important because you are making your network larger. Yeah. You are being inspired from the other people because the pace with which the technologies develop is so fast. You cannot do it only by yourself. It means you have to get out of this, I would say, glass ball in which you are once you are sitting in the office, and you have to get and be inspired by the other industries and other people around the world. Yeah? And I think if you ask about what is going to happen this year, there are a couple of them. I would mention maybe one or two. The one which I really like very much is the Innovation Roundtable Summit, which is going to happen about November frame time. And Innovation Roundtable Summit was started something like, I don't know, it's about 10 years ago. It's probably one of the biggest gatherings if you think about the corporate innovation. When the people from the corporates are coming together and they are exchanging the experiences, what works in one corporate versus another, and so on. And one big track during the Innovation Roundtable Summit is about the venture client units and what kind of experience the Bosch has from this, what kind of experience the Siemens get from this. And then I'm going to also share our experience from driving such kind of a hybrid organization, which you could read in the Forbes article as well. Yep. Which we have two, one in the West Coast, the A-Cube, another one up next. Which, in my opinion, we haven't touched too much on this today. But these guys are operating like in the startup mode. It means these guys are owned by Airbus, but they are separate subsidies with their own governance. And they are getting the projects on which they have to work on for maximum 2 years. They are hiring the people from outside and from inside for the project duration. And then once the project is coming to the end, then you are transferring the project to the mothership in order to continue and making the product out of this. Very good article, by the way. I like it very much, which I wrote, by the way. You could look on this one. And this is something what I am going to be talking about end of the year. And there are still a couple of the others ones which are coming around October and December frame time. But I would first focus on this one. And very important thing about that one, just finishing, is not just about the corporate governance and so on. It's also really taking the customer perspective and how you create the value for customer and how you make it, how you can measure it. Because at the end of the day, innovation is only then when you will solve the customer problem, which creates the value for customer. You could have the best innovation ever, but as long as it doesn't create enough value for your customer, it's still not making a difference to you and your customers. Therefore, customer perspective and how you drive it in order to create it in the, I would say, most efficient way is what I'm going to be talking about.
Greg, I look forward to doing a follow-up with you because your passion is clear, the portfolio is broad and exciting, and I just, I'm rooting you and the team on. Very exciting work. Again, for everybody that's going to be listening to this particular episode and watching it on our YouTube channel, you've been spending time with Dr. Greg Ombach, Head of Disruptive Research and Technology, Senior Vice President at Airbus, executing on their mission of a decarbonized, connected, autonomous future for all of aerospace. Greg, again, I want to thank you for taking the time out of your schedule to come talk to us, come educate us on all these themes. Obviously, thank you for what you're doing to create the future of aerospace. And as we like to say here on our show, thanks for helping to create a better tomorrow for everybody via what you do. It's such an inspiring and exciting story. And I look forward to doing it again next year at some point.
Ira, thank you so much for your time. And also thank you very much to everybody who is going to be watching it. Guys, you can reach out to me. You will find me on LinkedIn or other places. And then see you next time. And once again, thank you so much for your time and all the work, Ira, for doing it.
Great.
Very well done.